FutureMakers.
Let's make linkages. With this FutureMakers Spark, your learners will build mechanisms that move using push and pull forces on connected systems of levers and pivots. They'll imagine, plan, prototype, and create functional machines or mechanisms that bring a scene to life. This open-ended design and build challenge helps them understand the systems they engineer, explain how forces are transferred, and confidently engage in troubleshooting and critical thinking. Here's what each learner receives to make linkages. 2 die-cut cardboard bar sheets, 2 sheets of die-cut shapes, a sheet of plain cardboard, a set of special plastic fasteners, a visual guide, and a reusable reclosable bag. We encourage you to print a design sheet for each learner to help them imagine, plan, and prototype prior to making their final project. Your learners will also need paper, scrap cardboard, scissors, tape, and art supplies to create components for their mechanisms. To start, we'll prepare parts to practice with. Remove the long straight parts from one sheet of die-cut bars. We'll call these levers. Remove a fastener from the set. We'll call this a pivot. The parts have spaces for connectors. We'll call these pivot holes. Insert a pivot at the end of a long bar. Locate the hole in the end of another long bar and press the pivot through to connect them. The 2 levers should be firmly connected and slide on each other when they're moved. Linkages can move freely or have components that are fixed in place. These levers are connected by a free pivot. Your learners can find free pivots in everyday things. For example, these scissors pivot to open and close. Your elbow is a free pivot that allows your arm to bend. Some pivots need to stay in one spot so levers can move around them. We'll use cardboard to do this. Carefully create a starter hole through the cardboard with a pencil. Flip the pivot so the point faces away from the board. Insert another pivot and firmly fasten the lever to the board. Make sure the levers lay flat. You've created a fixed pivot. This will stay in place while other levers rotate around it. But what could we do with this? Let's expand on our example to create machines and scenes that move. When you push or pull on one end of this system of levers, the other end moves in the reverse direction. Everything moves around the fixed pivot. You can make a reverse motion linkage using what we've already created. Add one more free pivot and lever to the system. Notice that there's pieces that are added to guide the levers. These guides are essential to this design. It's easy to make a guide with another piece. Lay it over the lever you want to guide, and use it to poke holes in the board. Attach it with pivot fasteners. Leave it loose enough so the lever slides easily. We can create more precise guides with just the pivot fasteners. Poke holes on either side of the part you want to guide, and press them in so the part slides without coming loose. Adjust these as you need. Machines and scenes that use reverse motion linkages are great for elements that move sideways. What if you want things to move up and down? Systems that make levers move at right angles are called bell crank linkages. Where does that name come from, you ask? Long ago, if you lived in a castle and wanted a servant to bring you something, say a cookie, there was a rope you could pull to ring the cookie delivery bell in the kitchen. The rope traveled across the castle ceilings and connected to an angled crank that would move on a pivot and pull on a little hammer that would hit the bell, making it ring. These systems are great at creating machines and scenes with vertically moving parts that activate elements that move horizontally, and vice versa. But what if you wanted to move something sideways and up and down at the same time? Parallel motion linkages always stay parallel to each other. The top and bottom bars are the same length. The side bars are the same length. That makes this shape a parallelogram. This mechanism can move vertically and horizontally at the same time. You can create a scene with a component that rises and falls, or integrate multiple elements that slide and tilt to create complex interactions. But what if you could make something that had a longer reach or performed a useful function? Scissor linkages are systems of levers with pivots at the centers and ends. They're great for extending the reach of a machine in a limited space. A basic scissor linkage is just two levers that pivot at the center, like scissors do. You can connect multiple sets of levers together to create a mechanism that can extend far and retract into a small space, or perform a more complex function, like this one does. But what if you wanted your learners to go beyond just exploring linkages? Once your learners have created basic linkages, they're ready to try something more challenging. Linkages are designed and built of connections. The output of one machine can become the input for another. What if your learners could create a bigger machine from the ones they've already made? Their projects can be connected together to move in a larger system. Challenge them to pair off and see how their systems can combine. Encourage your learners to think about how they'll connect not only the moving inputs and outputs, but also how they'll connect the backing boards for strength. For an even bigger challenge, those pairs can then connect to another pair to make a 4-part mega machine. Learners may need to simplify or reinforce their components to get the whole system moving from a single force input. Linkages can be a multi-session project that starts with an open-ended challenge. You're there to guide them through the process of designing and engineering a solution. We've created a 2-stage design sheet that supports planning, prototyping, and final engineering of a unique scene or functional machine. Using their design sheet, they describe their scene or machine in one sentence and pick one mechanism to bring it to life. Their choices should be at a level that's right for them. By sketching their ideas, they'll be better prepared to confidently create. Sketching more than one idea builds planning and problem-solving skills. Have them label their mechanisms so it's clear how their elements might move. It's okay for them to tinker with parts and sketch at the same time. Encourage them to emphasize what they want others to see and disguise the less important parts of their mechanism. Strong sketches include elements they plan to make from scrap cardboard or other supplies. With sketches complete, learners can build a prototype. Let them know it's not the final version. Encourage them to draw and cut paper practice parts that can be attached with tape. With their prototype complete, learners are ready for stage 2 to plan their final project. Now they give their machine a title. They list up to 3 improvements that'll be made in their final version. Most importantly, they create a detailed final sketch with mechanisms that are clearly labeled. Final versions will require access to more art and craft supplies, so learners can draw, cut, and build features of their project that draw focus away from the mechanism and towards its function or story. Pivot fasteners have parts that sometimes get in the way or stick out in the wrong direction. Have your learners look closely to see what might be causing the problem and encourage them to troubleshoot. It might be as simple as removing and moving or reversing that pivot fastener. Learners often want to use as many components as possible in their systems, which often results in a linkage traffic jam. Encourage them to use as few moving parts as possible. Simpler systems work better. If learners need to replace a part or invent a special one, scrap cardboard is a free source of levers. Have them use the holes in another bar to create pivots that match the spacing of the ones we make, or come up with their own custom pieces. Their bag is a perfect place to store projects in process and all of their extra components. Congratulations on creating linkages. Every Spark your learners make is unique and theirs to keep. They'll remember the projects they made with you for years to come. Thanks for watching. Bye.
FutureMakers.